The problem is that the theory is so complicated that no human has been able to solve the consequences of this equation. That's where quantum computers can come in.
I think this is the biggest scientific discovery in my lifetime, and it stands with the great scientific discoveries of all time.
Did quantum computers just tap into the fabric of reality itself? Physicist Michio Kaku has issued a chilling warning. A recent breakthrough suggests quantum machines may have triggered what he calls the God particle plug-in, a direct interaction with the Higgs field, the force that gives mass to everything. This isn't science fiction. It's a wake-up call. If true, we're no longer just observing the universe. We might be rewriting its rules. Are we prepared for what comes next? What is the God particle, anyway? The God particle, a nickname for the Higgs boson, has captivated scientists and the public alike since its discovery in 2012 at CERN's Large Hadron Collider. This elusive particle is central to our understanding of why matter has mass, a fundamental aspect of the universe's structure. The Higgs boson is an elementary particle associated with the Higgs field, an invisible energy field that permeates the universe. According to the standard model of particle physics, particles acquire mass through their interaction with this field. The more strongly a particle interacts with the Higgs field, the heavier it is. The discovery of the Higgs boson confirmed the existence of this field, completing the standard model and enhancing our understanding of the universe's fundamental forces. The term God particle was popularized by physicist Leon Lederman to convey the particle's fundamental importance. However, many scientists prefer the term Higgs boson to avoid religious connotations. The nickname underscores the particle's critical role in the formation and stability of matter. While the discovery of the Higgs boson was a monumental achievement, it also opened new avenues of inquiry and concern. One area of caution involves the Higgs field's potential instability. Some theoretical models suggest that the universe exists in a metastable state, meaning that a high-energy event could potentially trigger a transition to a more stable state, fundamentally altering the universe. Additionally, as quantum computing technology advances, some scientists speculate about the possibility of these powerful machines interacting with fundamental fields like the Higgs field. While this remains speculative, it raises questions about unintended consequences and the importance of understanding the full implications of manipulating such fundamental aspects of physics. The discovery of the Higgs boson has been a cornerstone in particle physics, confirming key aspects of the standard model. However, it also highlights the vast unknowns that remain. As research continues, scientists aim to explore the Higgs boson's properties further, investigate potential connections to dark matter, and understand the full implications of the Higgs field's role in the universe's stability. The power and impact of quantum computers. Now, before going further, let's talk about quantum computers. They are machines that process data in a very different manner from the computers that we use day to day. Regular computers utilize bits that are either 0 or 1, but quantum computers utilize something called qubits, which are 0, 1, or both, simultaneously as a result of a bizarre property in quantum physics called superposition. What that implies is that quantum computers can test numerous possible solutions simultaneously, which makes them extremely adept at solving very challenging problems. They also utilize something called entanglement, where two qubits become connected in a manner such that when one is modified, it instantly changes the other, even if they are miles away from each other. Due to these capabilities, quantum computers have the potential to revolutionize many industries. For instance, they can assist scientists in creating new medicines more quickly by simulating how small molecules interact with each other. In meteorology and climatology, they can make it simpler to model and predict large storms or long-term changes to the climate. In finance and logistics, they can discover improved methods of regulating supply chains or optimizing shipping patterns. Quantum computers can even assist us in protecting against or cracking digital security systems. That is because current encryption, which protects banks and email, can be cracked by future quantum computers. That is why scientists are already developing something called post-quantum encryption, so they remain one step ahead of potential threats. Large corporations such as Google, IBM, and Microsoft are heavily investing in quantum technology. In 2019, Google reportedly achieved quantum supremacy when its quantum computer solved a problem in 200 seconds that would take a regular supercomputer thousands of years. However, today's quantum computers are delicate, expensive, and need ice-cold temperatures to operate. They also produce more errors than traditional computers, so scientists are working on ways to stabilize and make them more reliable. Experts estimate we may have useful quantum computers in the next 10 to 15 years. If that's the case, they have the potential to change the way we do science, technology, and even reality. But with that power comes great responsibility, and it will be important to use these machines wisely to make sure the benefits outweigh the negative. The anomaly that started it all. Last year, something strange happened at Google's quantum AI lab. Their quantum computer, nicknamed Willow, started producing results that didn't make sense, not just once, but over and over. At first, scientists thought it might be a simple glitch. Quantum computers use qubits, which are tiny particles that can easily be disturbed by things like heat or background radiation. This kind of disruption, called quantum decoherence, can cause errors, so an unusual result isn't always surprising. But what made this event different was how consistent the weird behavior was. Even after restarting the system and checking the code carefully, the unusual patterns kept coming back. That's when people realized this wasn't just a one-time mistake. Willow had solved a problem in under 5 minutes that would take a normal supercomputer more than 10 septillion years. This shocked researchers and made them question what was really going on. The mystery deepened when an AI system monitoring the experiment flagged it as an unclassified quantum event, meaning something so unusual that it didn't fit any known category. Some experts started to think that Willow might be showing us something new, something beyond the known laws of physics. The current model scientists use to explain the universe, the Standard Model, has worked well for many things, but it doesn't explain everything. It leaves out big puzzles like dark matter, dark energy, and how gravity truly works at the quantum level. One theory suggests that Willow's strange behavior could be tied to the Higgs field, a powerful energy field believed to give particles their mass. Normally, studying the Higgs field requires huge machines like the Large Hadron Collider, but if a quantum computer is somehow interacting with it, that would be groundbreaking. Famous physicist Michio Kaku even suggested that Willow might not just be calculating, but possibly affecting the very fabric of the universe. This idea is still very speculative, but it's gotten the attention of scientists all over the world. Now, other research teams are checking their own quantum computers to see if they notice anything similar. The event has also raised big questions about the power and safety of quantum technology. If these machines can reach into deep areas of physics we don't fully understand, they could bring huge discoveries, or possibly risks. That's why experts are calling for careful study and close monitoring. We may be on the edge of a new era in science, where computers don't just process information, but help us uncover the hidden rules of the universe. While no one is sure yet what Willow really discovered, one thing is clear: the world of quantum computing just got a lot more mysterious and a lot more exciting. Is the Higgs field being disturbed? Physicist Michio Kaku has ignited scientific debate by suggesting that a peculiar anomaly observed in Google's quantum computer, known as Willow, could signify more than just a technical glitch. According to Kaku, the system may have done something unprecedented, interacted with the Higgs field, sometimes referred to as the God field, due to its role in giving particles their mass. This provocative claim challenges our current understanding of how quantum systems function and how they relate to the fundamental forces of nature. The Higgs field is an invisible energy field believed to permeate all of space. Its associated particle, the Higgs boson, was famously confirmed in 2012 at CERN's Large Hadron Collider, LHC, after decades of theoretical work. Detecting or influencing this field requires enormous energy, so much so that it typically involves smashing protons together at nearly the speed of light inside kilometer-long tunnels. That's why Kaku's suggestion is so astonishing. Unlike massive particle colliders, quantum computers operate at the opposite end of the energy spectrum, on the quantum level, using superconducting circuits cooled near absolute zero. What makes the Willow anomaly so compelling is that it doesn't fit the expected profile of random random error or background noise, which quantum systems are often vulnerable to. Instead, researchers observed persistent, unexplained patterns in the system's output, irregularities that repeated under controlled conditions and could not be easily dismissed by known causes, such as electromagnetic interference or coding flaws. These patterns, Kaku suggests, may point to something deeper, a quantum computer inadvertently brushing up against the Higgs field itself. If true, the implications would be staggering. For one, it would mean that highly sensitive quantum systems might have the capacity to interact with or even influence fields previously thought untouchable without enormous energy input. Such a capability could rewrite parts of the standard model of particle physics and usher in an entirely new realm of scientific inquiry. Could quantum computers be used to study fundamental forces in a way we've never imagined? Could they even manipulate mass or inertia at a subatomic level? On the other hand, this also raises serious concerns. If a quantum computer can tap into forces like the Higgs field unintentionally, could it also trigger unpredictable or even hazardous outcomes? While Kaku is known for exploring bold scientific frontiers, he and other physicists urge caution. They emphasize the need for rigorous peer review, replication of results, and a clearer theoretical framework to explain how such an interaction could even be possible. Meanwhile, quantum physicists remain divided. Some are intrigued by the potential for quantum systems to serve as a new lens into high-energy physics. Others urge skepticism, noting that quantum computers are still in their infancy, and many of their anomalies turn out to be bugs or calibration issues. Still, as research continues, the Willow incident has become a case study in how emerging technologies may unexpectedly brush against the fabric of reality itself, opening doors to new knowledge, new power, and new responsibility. From simulation to manipulation. Quantum computers were initially designed to simulate the behavior of particles and atoms, essentially to model reality at the smallest scales. But what if they could go beyond simulation and actually manipulate reality? This idea, once considered science fiction, is now being seriously discussed by scientists worldwide. The recent anomaly detected in Google's quantum computer, Willow, has sparked debates about this very possibility. Traditionally, quantum computers have been used to simulate quantum systems, such as molecules and materials, to understand their properties and behaviors. This is because quantum systems are incredibly complex, and classical computers struggle to model them accurately. Quantum computers, leveraging principles like superposition and entanglement, can handle these simulations more efficiently. However, the unexpected behavior observed in Willow suggests that quantum computers might be capable of more than just simulation. As proposed by the renowned physicist Michio Kaku, these machines could interact with fundamental fields. If true, this means quantum computers might not just be observing quantum phenomena, they could be influencing them. This shift from simulation to manipulation has profound implications. For instance, researchers at the University of Maryland have begun using quantum computers to simulate the interactions of subatomic particles, a task previously thought to be decades away. These simulations are not just theoretical exercises. They could lead to the discovery of new particles or forces, fundamentally altering our understanding of physics. Moreover, recent studies have demonstrated that quantum computers can simulate complex particle theories in 2 dimensions, providing insights into the hidden forces that shape our universe. These advancements suggest that quantum computers are not only tools for understanding reality, but could also become instruments for reshaping it. The potential to manipulate reality raises both exciting possibilities and serious concerns. On one hand, it could lead to breakthroughs in fields like medicine, energy, and materials science. On the other hand, it poses ethical and safety questions. If quantum computers can alter fundamental aspects of reality, how do we ensure they're used responsibly? Furthermore, the idea that quantum computers might be tapping into or even creating parallel universes has gained traction. Google's quantum AI team has suggested that their quantum chip, Willow, could provide evidence for the existence of multiverses. While this remains a controversial topic, it underscores the transformative potential of quantum computing. What if the manipulation is already happening? For years, people around the world have noticed something strange. Memories that don't match what history books or the internet say. This strange feeling is often called the Mandela Effect. Some remember famous quotes differently, brand names spelled another way, or events happening that no longer seem to exist. While many experts say it's just how the brain works, mixing up details or misremembering, others think something deeper might be going on. Some researchers now wonder if quantum computers could be playing a role in these unusual experiences. If these machines are starting to interact with the Higgs field, could they also be affecting reality itself? Quantum systems work on the tiniest building blocks of the universe, where even the smallest changes might have big effects. If the God particle plug-in really has been activated, as some scientists fear, it might mean quantum computers are no longer just tools for solving math problems. They could be subtly shifting how space, time, or matter behave without us realizing it. Even though this sounds like science fiction, the truth is, we still don't fully understand how quantum mechanics ties into human thoughts or how we perceive time and memory. Some experts believe changes at the quantum level could ripple into our brains and change the way we see the world. And here's where things get more mysterious. Some believe that this might explain why governments are keeping parts of quantum research top secret. If reality can be changed, even slightly, it's no longer just science, it's power. Why Michio Kaku is worried. Dr. Michio Kaku, a renowned theoretical physicist and futurist, has long been an advocate for the transformative potential of quantum computing. However, recent developments have prompted him to voice concerns about the rapid advancement of this technology without a comprehensive understanding of its implications. In a recent discussion, Kaku highlighted the unprecedented capabilities of quantum computers, stating, "Quantum computing will push the limits of human knowledge, new science, new engineering, all leading to processors that compute using the very same atomic forces that created the universe." This statement underscores the dual nature of quantum computing, its immense potential to revolutionize various fields, and the inherent risks associated with manipulating fundamental forces of nature. Kaku's apprehension stems from the possibility that quantum computers might inadvertently interact with aspects of the universe that are not yet fully understood. For instance, anomalies observed in quantum systems, such as Google's quantum computer Willow, have raised questions about whether these machines could be influencing the Higgs field, a fundamental field responsible for giving particles their mass. The concern is that, without a thorough understanding of these interactions, we might be venturing into uncharted territory with unforeseen consequences. Kaku warns that while quantum computers are powerful tools, they could also become unpredictable if not carefully managed. Furthermore, the integration of quantum computing with artificial intelligence amplifies these concerns. The fusion of these technologies could lead to machines that not only process information at unprecedented speeds, but also make decisions beyond human comprehension. Kaku emphasizes the importance of establishing ethical guidelines and safety measures to ensure that these advancements benefit humanity without compromising safety. In his book, Quantum Supremacy: How the Quantum Computer Revolution Will Change Everything, Kaku explores both the promises and perils of quantum computing. He envisions a future where quantum computers solve complex problems in medicine, energy, and beyond. However, he also cautions against the potential dangers of unchecked technological growth. As we stand on the cusp of a quantum revolution, Kaku's insights serve as a reminder of the responsibility that comes with innovation. Government labs and secret projects. The recent anomaly detected in Google's quantum computer, Willow, has not only intrigued scientists, but also caught the attention of government agencies. The possibility that a quantum computer might interact with the Higgs field has profound implications for national security, energy, and defense technologies. In response to such developments, the U.S. government has intensified its focus on quantum research. The National Quantum Initiative, established to coordinate federal efforts in quantum information science, has been instrumental in advancing quantum technologies. Agencies like the Department of Energy, the National Institute of Standards and Technology, and the National Science Foundation are actively involved in this initiative. Moreover, the Defense Advanced Research Projects Agency has launched the Quantum Benchmarking Initiative, aiming to evaluate and accelerate the development of utility-scale quantum computers by 2033. Companies such as Rigetti Computing, IonQ, and Quantinuum have been selected to participate in this program, highlighting the government's commitment to transitioning quantum computing from theoretical research to practical applications. State-level initiatives are also gaining momentum. For instance, New Mexico has introduced the Quantum Moonshot program, seeking substantial funding to position the state as a leader in quantum technology. This program aims to leverage the state's existing research infrastructure to develop quantum technologies for both civilian and military applications. The integration of quantum computing into national defense strategies underscores the technology's potential impact. Marine Lieutenant General Stephen D. Sklenka emphasized the urgent need for quantum communication technologies to secure U.S. military networks against adversary intrusion, highlighting the vulnerabilities of current systems and the promise of quantum solutions. Are we ready for what comes next? The consistent anomalies observed in quantum systems raise critical questions about our preparedness to handle the implications of advanced quantum technologies. Physicist Michio Kaku has long cautioned against the rapid advancement of technologies without a comprehensive understanding of their potential consequences. He warns, "We're building machines that can crack open the engine of the universe without reading the manual." The potential for quantum computers to interact with fundamental aspects of reality, such as the Higgs field, suggests that we may be on the brink of discovering new physics. This prospect is both exciting and daunting. While the possibilities for advancements in medicine, energy, and material science are immense, the risks associated with manipulating the very fabric of the universe cannot be ignored. The integration of quantum computing with artificial intelligence further amplifies these concerns. The fusion of these technologies could lead to machines that not only process information at unprecedented speeds, but also make decisions beyond human comprehension. Ensuring that these advancements are guided by ethical considerations and robust safety measures is paramount. As we stand on the cusp of a quantum revolution, it's imperative to approach these developments with both enthusiasm and caution. Embracing the potential of quantum computing requires a balanced approach, one that prioritizes understanding, ethical considerations, and proactive governance. We hope you enjoyed this video. Stay tuned for more amazing stories.